confusing the bonus, it's okay. It's a good place to be confused. You can fix the place. All right, guys, let's take a look at these. So, part A, we already talked a lot about this, but what do I do first?
Subtract out of 1.
Yeah, got to get the radical by itself. For both sides.
7 minus 3x.
There's no square still there, good God, right? It's dead.
Subtract 7. X equals 9. And divide by negative 3.
That's it. It's a radical, so we got to check it, right? So 1 plus the square root. If I put a negative 3 in there, I get 7 plus 9 is 16. 1 plus 4 is 5. Check.
There you go.
Yay. Go plus. All right. Part B, exact same problem, just one twist. So still subtract 1. But now I do what?
Square root.
Square root.
Plus or minus.
Plus or minus. 7 minus 3x equals plus or minus 2.
Subtract 7.
Subtract 7.
And divide by negative 3.
Divided by negative 3. So we get x is negative 7 plus 2 divided by negative 3 and negative 7 minus 2 divided by negative 3. Right? And then I can figure out what those are. Is that cool? Plus or minus, I can break it out. Negative 7 plus 2 is negative 5 over negative 3 is 5 thirds. Negative 7 minus 2 is negative 3. Alright. So you don't want to become a math teacher as a former auctioneer, I think. No, 3. And then part C, same first step. So my whole point is find out where your x is stuck. Get that piece by itself first. And now instead of actually doing kind of something to both sides, what do I use? What do I do now?
7 minus 3x equals 4.
Yeah.
7. 3x equals negative 4.
I like it. So then you subtract 7, divide, you get x equals 1. Subtract 7, divide, you get x equals
11 over 3.
Cool. But they all have the exact same first step. Get the thing that has your x in it by itself first, because then you can attack that thing. Either directly with an inverse function or indirectly with an idea. I like that. Attack it with an idea. Order fire. Alright.
We have to check our answer here.
What's up?
We have to check the answer.
Nope. Sure don't. Because right here, I knew I was going to get valid answers because it equals positive. Yeah, right here will tell me if it was a negative 4, then I should stop. So if you're careful, you should never have to check your answers back to back. Part D. What do I do first?
Subtract.
That's crazy. Right. And now I apply the inverse. I rewrite this in the inverse way. So what would that look like?
2 to the 4.
2 to the 4th
7 minus 3x.
equals the inside. That's important. Right. Being able to rewrite it from logarithmic form to exponential form.
16.
Yeah, 16. Subtract 7, you get 9, divided by negative. It's kind of nifty. Now if you check it, you got to check it, right? Yeah, sure, whatever you say, Jeff. 7 plus 9, thank God, it doesn't make the inside negative, right? What is log base 2 of 16? 4 plus 1.
5.
Yay! Anybody do the bonus one?
5.
What'd you get?
I got 5 over 3.
I got a little. Yeah, that's it. So, real quick, just to show you, this is bonus, but just to show you. So again, the first step is always, there's where my x is, let me get rid of the stupid 2. Holy crap, I'm way there. What kills f? F inverse. So I do the F inverse of both sides. Wow. Give myself some room. apply F inverse to both sides. F inverse of that side, F inverse of that side. These die, just like squaring a square root or so forth, right? So I get 3x minus 7 equals, and now you see why I had to tell you this. What's F inverse of 3? Negative 2. Add 7, divide by 3. Okay. So this is a generalization of all the problems we did in number 1. You get where your x is stuck, and then you do the opposite function to it. So I don't even know what this function is, but I can still solve it if I have just a little bit more information right here. Okay. So if you didn't quite get that, it's okay. It's a bonus idea. Let's go over number 2, because these should be easy, but it's getting to the idea of like terms, like we said earlier. What's 2x plus 3x? Okay, thank God. So now what's 2 of these plus 3 of these?
5.
Now watch. Couldn't you pull this back up? Let's do this a different way. Let's do this a silly way. How would I rewrite this? Natural log of x squared plus natural log of x cubed. What do I do with this when it's addition? It's the ln of rack. When you're adding logs, what do you do?
X squared.
Good. X squared times x cubed. The natural log of x to the 5th, is it the same answer as what we got? Yeah. Just one has a 5 up and one has a 5 down. You can see why I said that's the silly way. Good God, it took forever. There are like terms to begin with. Why would I do all that shit? Just put them together. Well, you're always looking for like terms. C. What can I do with that? Excellent. Done. Sweet. That is a possible answer. So what about part D? Same thing. That was the point I made earlier. Those are not like terms the same way that the stuff in part C are not like terms. The exact same way. So I'm done. That's all I can do. I could pull an X out, but it says simplify, so I can't put those together, so I just stop. So then what about part E? Are those like terms? No, but I do have a property that I can use.
8.
Careful. What's up?
ln 8 divided by 4.
Yeah, I'm subtracting powers. I must have been dividing, right?
Yeah, so you got ln.
What is the base in both of those known to be?
2.
No, what's the base of both of those? E.
So
8's not a base or anything. So natural log of 2. So in the same way here, this is sort of like that one that was on the test. How can I rewrite this?
x squared minus x divided by x.
Yeah, the difference of 2 powers must have meant I was dividing the stuff. And of course here, I cannot do this.
No.
You can't break into subtraction, but you can take an x out and kill it. So just get natural log of x minus 1. I like it. So it's just like that one that was on the test. Some of you guys had something left on the top, and some of you guys had something left on the bottom, but whatever. Part G, are those like terms?
Yeah.
Here I got 1 log b 3x, and here I got 1 log bx.
Yeah.
I don't have 2 of anything. I have 1 log b 3x and 1 log bx. So I can't add them, but I can apply a property. I really want to make a distinction between those two. I cannot add those. They are not like terms. But the logarithm function has properties. Logarithm. Yeah, multiplication. Exactly. So this would be log base b of
3x squared.
3x.
u. No, I'm always wondering. I cannot bring that 2 down. Let me see why.
Is this inside the parentheses?
It's not. Yeah, you can only bring it down if it's on the whole thing. Is the whole 3x being squared? No, so I can't bring it down. I like it. If that would have been all of that squared, then I could bring it 2 down all day long. Alright, it's a little side note. So take a minute and do number 3 if you haven't done that yet. Notice I'm not asking to graph them. If you want to rewrite them, go ahead. You shouldn't have to. You should be able to identify them the way they are.
Jeff, do you have this question? Because I don't have.
Oh, you don't have that? Well, shit. That's all right. You're sitting there like, man, I'd really love to be a part of this. It should have been, it wasn't with all this stuff they gave you. Okay, all right. Damn it. All right. All right, so this is a you get it or you don't situation. Which one is a parabola? That's the one that should be very different from the other ones.
The one.
Which one's a parabola? Parabola. Which one? Not D.
No,
C.
C.
C. What's the big difference with part C versus everything else? Yeah, in everything else, the x and the y are both squared. So you're curving in both kind of directions and so on. The C, it's only the x is squared. Okay. Alright, so now we know C is parabola, so that's what you look for. We know that a parabola is y equals x squared or x equals y squared. Only one variable squared. That's how you can identify it very quickly. The circle should be the next easy thing.
D.
Yeah, why B?
Because both was inverse.
Because these are both, no, everything else is all squared. That's not why. They have the same coefficient. So that was 2 and 2, 7 and 7. It would go the same amount in both the x and y direction. That's a circle, right? Symmetric in all directions. You guys get that? So see, look at the difference in part A. Do they have the same coefficient?
Nope.
Oh, shit. In part, oh, shit. In part D, same thing. Now, what distinguishes between ellipses and hyperbolas? Yeah, hyperbola subtraction. So which one's A? Subtracting. That's a hyperbola. That's a hyperbola that opens on what axis? Is sitting on which axis?
Oh, the x?
The x, because the x would be the, once you divide by it, it's going to be the positive one, right? That's what you look for. That's the one that can actually have real intercepts. So that's where it's going to sit. And the D is an ellipse because there's a plus. Now, I know there's other things you can notice. What would I have to do here to get it in the right form? I'd have to complete the square here, right? This guy is the nicest one because I just, what's the only thing I have to do to this?
Divide by 25.
Yeah, I need a 1 there, so I divide by 25. I can see what my A is and what my B is then, right? You guys, does this all sound vaguely? I liked most of you guys got, I didn't really ask too much of you because it's really just a matter of, are you able to pull from the equation what you need? If anybody's going to pre-calculus, it's a really good base to have because then you're going to get a little deeper into it. Get a little more specific. You're going to definitely do foci. You're going to do weird-ass eccentricity thing, which is how elliptical are you, is the eccentricity. So we didn't even get all that. But anyway, that's in your future if you're doing that. What else did I want to say? Oh, yeah. So for the circle, you'd have to complete the square for the y. Do you guys see that? But not for the x, because he doesn't have any x pieces laying around. All right, those are the kind of things you want to start getting used to looking for. Okay, cool. Yes, sir. B, the coefficients are the same. I really want this to make sense, and that's why it's a circle, because it's going to be the same in both the x and the y direction, whereas D, there's a 2 on the y squared, it's going to be squished or something, right? One direction is going to be different than the other. That's the ellipse. Cool. All right. I didn't really try to make them, if you try to graph them, I can't say you're going to get nice radius or anything. I just threw shit up there to be something. Okay. Where do you want to go next? If you want to take a break, you can do that anytime, I guess. I'm going to open it wide open. I'll go ahead and give you the answer key for the practice final. Anybody need a blank practice final? Oh, one of those. So, as normal, I got to like 4 pages worth of the answer sheet, so there's a few more to do on the end. I just didn't want to do a 5th page. So we'll do those together here in a minute.
Tomorrow's the last day.
Now, you know, I don't know if you noticed the length of the practice final, right? The actual final will be a little bit longer, so, no, I'm joking. The actual final. Oh, Jeff, that's so funny. It'll just be a little bit longer than a normal test. So, normally have about 25, you know, counting A, B, C, D. So it's going to be just below 30 maybe, so.
How bad?
I should do some homework.
You ready?